Presenting to you guys experiment 2 liquid-liquid extraction.
Assalamualaikum, I am NURAIN ATIQAH binti AHMAD ZAPWAN.
And I am Syauqina Afiqah binti Muhammad Sukri from RS 2452C.
Objective. The objective of the experiments are to separate acetic acid from its solution using water as an extraction solvent and to determine the mass fraction of acetic acid in extract and raffinate layer.
So now let's see to introduction to liquid-liquid extraction. Extraction of liquid is the separation of the component of liquid mixture using a solvent. So this entails bringing a solute from binary solution into contact with a second immiscible solvent, in which the solute is soluble in its simplest form. So, however, numerous solutes may be present in original solution, and this solvent extraction may consist of mixture of solvent intended to be selective for one or more solute, depending on their chemical formula. The solute partitions between two immiscible phases are separated in a single-stage liquid-liquid extraction, in which the initial feed solution is agitated with a suitable solvent, which is allowing the solvent containing the extracted solvent to be divided into two phases before being decanted. A single extraction process yields two products, which is extracted feed solution, we call it as raffinate phase, and the extracted solution including solvent, we call it extract phase. In this experiment, one phase is aqueous and another one is an organic solvent such as water used to extract acetic acid from its chloroform solution.
Procedures in liquid-liquid extraction. Step 1. 4 ml of acetic acid was added to 5 ml chloroform in separating funnel to prepare a binary solution. We didn't put the stopper into the funnel in order to avoid pressure burst. Step 2. Our feed solution was swirled gently with the funnel mouth still open to make sure the solution was mixed well. Step 3. 10 ml of distilled water was measured using measuring cylinder and pour it into the funnel. We need to be careful as this mixture may generate a lot of vapor. Next, a protective equipment which is glove was wear and the funnel was shaken gently with the stopper on. After that, the stopcock was opened to release pressure build up. The funnel was shake and venting continuously for 5 minutes. Step 5. When the funnel was put on the O-ring support, its content was settled into phases. The heavy and light phases was allowed to reach the equilibrium after waiting for about 5 until 10 minutes. Step 6. To clean empty conical flask was weighed and each phases was transferred into each flask. Then they was reweighed again. Lastly, 2 drops of phenolphthalein was added into each flask to detect alkaline ions, and then the phases were titrated with 2 molar of sodium hydroxide. How do we know if the solution reached endpoint? We know when the pink solution turns colorless.
So let's move to result and calculation. So now this is the result and the calculation is shown in the table 1, which is chloroform acetic acid water system. So this is result and calculation for this part, which is A, mass of raffinate and extract, and B, titration data, which is both of these we can get from the experiment, which is mass of raffinate that I get from the experiment is 5.414 gram and also extract 14.538 gram. So now let's look at the calculation that I show you in this slide, which is on how to find mass fraction acetic acid in raffinate XR or extract, which is YE. So first of all, we need to find the chemical equation, which is acetic acid react with the sodium hydroxide. We will produce CH3COO and A plus H2O. So first of all, we look at the step. First of all, we need to find the mole acetic acid in raffinate. On how to find, we can use information given, which is mole NaOH with the formula Mv over 1000. Why we use mole NaOH? Because NaOH will have the full information, so we can make the equation from that. So then after we get the mole NaOH, it's similar with mole acetic acid, and then we convert the mole to gram, which is the mole acetic acid convert to gram, because our mass before this we get in grams, so we need to change it in grams. So at the end we get 0.06 because we dividing on the gram that we get from the experiment. By using the same chemical equation, we can find the mass fraction of acetic acid in extract. By using the same step, which is find the mole acetic acid in extract, same goes, we also use the mole NaOH because it full information, and then convert it to gram. After that, we find the mass fraction of acetic acid with dividing the mass that we get from experiment. So the answer will be 0.2553. So now let's look at the ternary phase diagram for chloroform acetic acid water. For this part, I will share with you on how to read XR and YE from the graph. So first thing first, the mass of acetic acid, chloroform and water were calculated by multiply volume with the density. After that, the value of M, which is total mass, was calculated using F plus S. F means feed, S means solvent, and we will produce M as a total mass. So then the mass fraction of SF is 0.3621 that our group get it, and it was plotted in the graph on y-axis, which is what is mean with y-axis, which is acetic acid. So the value of Xm can be calculated because ys is equal to 0. So from the calculation, we got Xm is equal to 0.1948. So the last one plot the Xm on the y-axis, make a straight line. The overlapping that we balancing overlapping point was marked, and then the theoretical value for the mass fraction of acetic acid in raffinate and extract can be determined.
Although the experiment was proven a success, there are several recommendations that students can apply to increase the quality of experiments. Firstly, we should ensure that the eyes are perpendicular to the meniscus while using measuring cylinder to avoid parallax error. Secondly, We should ensure the titration is done carefully and slowly, since the endpoint of the titration process can come abruptly. Thirdly, wear proper personal protective equipment PPE such as gloves while conducting an experiment.
So now I would like to share the last part, which is conclusion. In this experiment, we will perform a single stage extraction to separate acetic acid from its solution in chloroform using water as an extraction solvent. The acid contains in the raffinates and extract phases were determined by titration with sodium hydroxide, which is NaOH, and the results are compared to the theoretical result.
That's all. Thank you, madam, for spending your time. Your time and effort is much appreciated.